Okay, so here's what we had last class at the end. We had our aggregate expenditure function, our 45-degree angle production function, and yes, they meet at some value, a y star value. Just kind of a little FYI, by the way, these 2 points, if I put a point over here, would have the same numeric amount because, again, that scale of 1 to 1 of our 45-degree angle production function. If this is 1,000, this point has to be 1,000. So I made this y star just again, just kind of it's our equilibrium point. If you want to call them y1, we could do that too. I wouldn't object there. This represents long run equilibrium. So our long run real GDP. Very early in the semester, most of you probably don't remember, and that's totally okay. We talked briefly about a term called potential GDP as kind of your long run. And it was, remember when we looked at the data, we said it would be kind of like a trend line and that we have short run deviation away from potential GDP, and that's where we saw things like expansions and recessions. If we kind of use that same thought process, this model does help us at least capture those short run effects. A little poorly, but it still does capture them. And again, if we could do a little bit more of the math behind the model, it would capture them much better. But we're kind of skipping over that calculus stuff. So again, if we think of this kind of this y star, this y1, whatever you want to call it, as our long run real GDP potential, we can talk about deviation away from that potential. So hypothetically, for example, let's just say that we were somewhere over in here in our graph. If we're over in here, that means we're operating in this realm. In this realm, you'll notice that our spending is greater than production. Right? At any point right here, spending exceeds production. In essence, what is happening in the economy? It tells us that people are buying products that are not being produced. So people are buying up products. Now they have to have been made at some point. They're just not being produced now. So they were made before and produced and stored in inventory. In fact, that's, I think, actually formally how the textbook kind of relates to this. They say this is an area where stored inventory is falling. So we sit there and say, where does this occur? Well, this probably occurs right after the trough of a recession, because we talked about the idea that that after a recession, firms kind of they don't respond immediately. They don't just start producing right away. It takes them a little bit of time before they've decided the recession is over, and then they're going to, and we phrased it this way earlier, they're going to sell off all their inventory that they had produced before, and people stopped buying before they start looking to hire people. So what this tells me is if that we're in this kind of situation where we are seeing periods where expenditure is rising, and again, tracked inventory, they do track that variable. Where tracked inventories are falling, this is probably an indication that we are moving from a trough to a recession into an expansion phase. And again, you can kind of see that if I just name this anything, kind of like y question mark, because it doesn't really have a name. What's happening? Well, we're going to start moving back towards that long run potential. We're going to start moving back towards that long run trend. And as we move back towards that long run trend, again, kind of just stealing a graph from earlier this semester. You don't need to write this down in your notes or anything, right? We had kind of this. Ooh, that's a really bad version of it. Maybe I'll do my trend first. Right, we kind of had this long run trend, and effectively as we move back out of a recession towards that trend, here's what we're seeing. We're seeing those periods right here where we've got to a past our negative deviation from our trend and so on and so forth. Yeah, it's a bad graph, and again, you don't really need that. Conversely, what if we're over here somewhere? Again, y question mark in blue. Well, that tells me that I'm operating somewhere up in this region. In this region, you will now notice that production exceeds spending. In this case, goods are being produced, but people are not buying them. Goods are being produced, but people are not buying them. And again, the textbook, the official tracked variable that identifies this is we look at it and we see that inventories are starting to rise. So goods are being produced and people are not buying them. Again, we talked about when this occurred with that impact of a recession, and firms aren't going to say, hey, we had one bad day. We had one bad month. We had one bad quarter. It probably takes at least a quarter before firms start thinking about changing behavior. And again, if not, we would say every January was a recession. So it's going to take at least a month for firms to start thinking about changing their behavior, at least a quarter, and probably longer. And during that entire period of time, they're still going to continue to produce goods. So production is still going at some level, but, people aren't buying those goods. As their inventories start to rise, that is when firms get that cue. They're looking at their inventory numbers, they're going up, it's time to stop producing. This tells me that probably this why question mark is probably kind of just the opposite. We've hit the peak in the economy and we are starting on the downward slide back to that trend line, back to that norm. So we're starting to move back down. Probably a very good indication that a recession is coming. And again, in fact, they track this variable. It is usually very predictive. We can definitely start noticing inventory increase and recession coming shortly thereafter. It's probably within a year time frame. So, again, this is something that maybe even shorter than that. It's not a really long run predictor. But if we start seeing this consistently, and we're not in January and February, it's probably a pretty good indication that we're about a year or less out from a recession. So, just to go back to my little bad graph here, it's again, after we've peaked and we're kind of heading back to that norm. So it does give us some use as a short-run model. It's not the best short-run model, but it does give us some use as a short-run model. And again, if we could do the calculus and find areas under the curves, we actually can get a little bit more information from that. So it does have some benefits in that regard. We for the most part, again, this is a really good predictor. Rare situations, it might be even more rapid. So we saw after 9/11, and I think we're seeing it now, that we're actually getting just a sudden stop of spending. Again, that happened after the 9/11 terrorist attacks. That seems to be happening right now, where maybe that's a little askewed. So very possible, in fact, probable a recession is coming. A lot of the data has been predicting it. All of a sudden now we're definitely in a production exceeding spending, and firms are not waiting a month or 2 months or a quarter or 2 quarters. We're already seeing firms just right off the bat saying we're cutting employment. That's very atypical. Again, normally this is a much better, longer indicator. Still a short term, under a year, but not like today where it might be within a few days. In terms of firm's decision. So just kind of wanted to throw that out there. Okay, so now we have kind of the short run impact in this model. We want to kind of start thinking about the long run impact with this model. Specifically, when I say long run, I want to look at long run change. I want to look at GDP growth because that's what we have. Keep in mind my same disclaimer of all time that I've always used. I might look at GDP shrinking. I might just make the model go down. We haven't observed that over a long run, but I'm going to still probably throw some questions out there for it. So I'm going to go ahead and kind of basically look at some model change, and then we'll have to kind of talk about some of the math behind it real quick. So I'm going to start with just kind of the starter graph, if you will, for this aggregate expenditure model. So all of these aggregate expenditure model starter graphs are all going to look the same way. Right, I have my 45-degree angle production function. I have some measured aggregate expenditure function, and some y star value. I do not need a value on the vertical axes over here, because remember, whatever y star is, or y1 if that's what we wanted to call it, it's going to have the exact same value, y equals AE. And then let's start talking about change. There could be things that happen to change our economy. And again, this is a Keynesian model. Keynes said spending is the root of everything. Spending is the driving force, which means we could see a change in spending. Something could happen and it could cause our expenditure to increase, right? It could drive aggregate expenditure up to AE2. And if it increases aggregate expenditure to aggregate expenditure 2, look what happens. We see an increase in long-run real GDP. The distance from Y1 to Y2 represents economic growth. So kind of just a quick comparison in the two models, you'll notice that a change in Y brought about by a change in any of our curves, in this case it has to be the spending curve, actually is going to create growth. Temporary deviation from Y is our business cycle activity. So remember we looked at business cycles versus growth. This model also has a business cycles versus growth interpretation. Now, one thing that we want to look at, and this is kind of odd, kind of interesting, let me get a color again here, is remember whenever we put the graph up last time and it had all the different color lines, and I said the distance between any of those lines just represented the addition to spending, which means the distance between my functions here at any point, and I'm just going to use the axes, should effectively represent my change in spending in the model. How about for simplicity, let's say that I change, investment changes. Again, just as an example. Let's say that I goes up $1,000. Again, that's just an example. What impact should that have on GDP? Well, let's see, I remember my formula, y equals c plus I plus g plus nx. And then I'm going to change I by $1,000, right? So I is going to go up by 1,000. Okay. So plus 1,000, right? Well, mathematically, how should y change? Well, whatever you do to one side of the equal sign, you have to do to the other, right? So I added 1,000 to the right side of the equal sign. I should add 1,000 to y. If we look at my graph now and just kind of think about this in terms of distance, right? If at any point on the graph, so right here at y1, this distance represents 1,000, then I could say, well, because each axis is measured effectively in dollars, if I said that y1, again, whatever number this is, has the same value over here because it's measured in dollars, if this distance is 1,000, that tells me that this distance out is 1,000. So now we have a problem because, right, if I have a plus 1,000 for I, our equation says plus 1,000 for y, and since everything is the same scale, it's all measured in equal amounts, dollar to dollar, that's how we got our 45-degree production function. That tells me that this distance is $1,000. It has to be true on this axis here. You'll notice the distance from y1 to y2 is not 1,000. It looks significantly greater. So the question is why? You know, I'm a terrible artist, and I've admitted that numerous times. So is it just an art issue? In this case, it is not just an art issue. We actually notice an impact greater than our original change. We had that a few videos ago. I'll have to say videos because the way we're filming these, it was like yesterday. We had that a few videos ago where we had a multiplier variable. If you remember the money multiplier, right? We had a $1,000 bill and we passed it all around the invisible classroom. And we said that well, that money effectively was being reused and we got extra transactions. We actually have the same impact here. We have what is called a spending multiplier. And we want to use this to mathematically show this difference between y1 and y2.